Let's look at the practice exam 2, problem number 3. Right, so we want to find all critical numbers of this function. Right, so this function is defined everywhere. So anything that makes this function derivative equal to 0 or derivative undefined will be a critical numbers. Right, so let's take the derivative. So f prime of x is equal to, right, so you have two things multiplied together, so we're gonna have to apply the product rule, right? So derivative of the first guy is let's see, put 4/5 in front, x, and subtract 1 from the power, so it's negative 1/5, right, times the second guy, which is quantity x minus 5 squared, plus, right, first guy, so I just copy the first guy as it is, so x to the 4/5 power, then multiply by derivative of the second guy, so put 2 in front, keep the same inside function, and subtract 1 from the power, so it's the first power, I'm not going to write it down, then multiply by derivative inside, which is 1 anyway, so I'm not going to write anything down, right? So we have this guy. Alright, so the next step would be we want to combine these guys together. So we're going to do, let's see, first I'm going to put the 5 on the bottom. Alright, so that would take care of this 5. And also x to the negative 1/5 power. So x to the, so negative power puts x on the bottom. Then you put 1/5 power. Alright, then you have on top 4. And also x minus 5 squared, right? And for this guy, what we're going to do is we're going to actually take the common denominator, right? So there's no denominator, so I'm going to multiply top and bottom by 5x to the 1/5 power. So we have 5x to the 1/5 power, right? Then you see that the 5 times 2 is 10, so I'll have 10 here, right? Then x to the 1/5 times x to the 4/5 would be just x, right? So that will take care of 2 and x to the 4/5. This has been already taken care of. And then you have x minus 5, so we put that in. Alright, so let's combine these two quotients together, right? So we already have the common denominator, so it's 5x to the 1/5 power, right? And what's in common? So this is even, that's even, so I'll pull out 2. And also you have x minus 5, so I'm gonna pull out the x minus 5 as well, right? So what's left from the first term would be, alright, so pull 2 out, so there's 2 left. Then you have another x plus 5. So I'm going to distribute 2 to x, 2x, and 2 to negative 5, so it's negative 10. Alright, then here we took out, let's see, x minus 5 and 2, so that would be 5x left over. So it's going to be plus 5x. Right, and clean that up a little bit, so you're going to have, right, 2 times quantity x minus 5 times, right, 2x plus 5x is 7x minus 10 divided by 5x to the 1/5 power. Alright, so let's set this guy equal to 0 so that we can find a critical number. Alright, so in order to make this guy equal to 0, we just have to make the numerator equal to 0. So you can see that here, right, x equals 5 is one of them, so x equals 5. Right, another one, so we want to make this guy equal to 0, so x has to be 10 over 7, right? 10 over 7. Maybe I shouldn't skip that. So all I did was 7x minus 10, set it equal to 0. then add 10 to both sides, so you have a 7x is equal to 10, and then you can just divide through by 7, so that will get you 10 over 7. So that's how I got 10 over 7. Right, so those are the values that make the first derivative equal to 0. Right, but we have to look for the other kind, that derivative is undefined. Right, so here's a derivative, and the only place this can be undefined is when the denominator equal to 0, so when x equals 0. So that's another, so since the f prime of 0 is undefined, therefore x equals 0 is also a critical number. Right, so there are 3 critical numbers. So critical numbers are x equals 0, that's the smallest one. Next one is probably 10 over 7, and the largest one is 5. Right, so those are the critical numbers that we were looking for. Right, that's it. I hope that this was clear.